Hi, thanks for joining me. Today I've got a fun function problem. We want to find all functions f from the reals to the reals, so it takes in a real number and spits out a real number, such that for any a, b in the reals without the rationals, so in other words, for any irrational numbers a and b, f of a times b is equal to f of a plus b. Okay, so this is sort of a weird definition of f, or a weird property of f, but we want to find all functions f with this property. Okay, so if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so I guess the first thing we notice is that f here is trivially satisfied with the function, or any constant function. So in other words, if f is a constant function, then this thing here is definitely satisfied. So for example, if f took the value 1, regardless of the input, i.e. f was the constant function 1, and the left hand side here, fab, is always going to be 1, and the right hand side will always be 1. Okay, so clearly all the constant functions are kind of obvious solutions, but we want to know, are there any other functions that satisfy this thing here? And the answer is no, but of course we've got to prove that. So the way I'm going to prove that is show that if we have a function f which satisfies this property, fab equals f of a plus b, for any irrational a and b, then it follows that f must be constant. And the way I'm going to do that, or the thing I want to prove, is that f of t is equal to f of 0 for all real values of t. Okay, so obviously if I can prove this, then it's quite obvious that f is a constant function, taking whatever value we prescribe to f of 0. Okay, so supposing f satisfies this property, we want to show that f of t equals 0 for all t in the reals. Okay, and the way we're going to do that is just look at different values of t. So the first thing we're going to look at is negative irrational numbers. Okay, so let x be an irrational number with x less than 0. Okay, and we want to show that f of x equals f of 0. Okay, obviously x is less than 0. That implies that minus x is bigger than 0. Okay, and now what we want to do is look at values of a and b to plug into this thing here to work out that f of x equals f of 0. Okay, now because x is irrational, surely minus x is as well. And then of course the square root of minus x, which makes sense because minus x is positive, the square root of minus x is also irrational because of course if the square root of minus x was rational, then square both sides, you get minus x equals rational, which contradicts this thing here. Okay, so we have that the square root of minus x is irrational. So what I want to do is set a equal to the square root of minus x and b equal to minus the square root of minus x. And when we plug those two back into this guy here, on the left hand side we get f of ab, so f of square root of minus x times minus the square root of minus x, which of course is minus x, which is of course just f of x, and that equals square root of minus x minus the square root of minus x, which is just 0, so equals f of 0. And we're done. So we've shown that for irrational x negative, f of x equals f of 0. The next thing I want to do is show that f of x equals f of 0, where x is a positive irrational number, and then we'll move on to the rational case and we'll be done. Okay, so now what we're going to do is let x be a positive irrational number, and we want to show that f of x equals f of 0. And the way we're going to do that is actually use the thing that we just showed, that for any negative irrational number t, say, f of t equals f of 0. Okay, so what we're going to do is in fact have a equals b equals negative the square root of x. Firstly, x is positive, so the square root of x makes sense, and we're taking the negative of it. Because x is irrational, the square root of x is irrational, and therefore minus square root of x is irrational. So setting a equals b equals minus root x ensures that a and b are both irrational, so we can plug them back into our f sort of property. So fab then, we know it's just f of minus root x all squared, which is just f of x. But we know that that's equal to f of a plus b. Okay, but f of a plus b is just, memorize it here, f of minus 2 root x. And now we know that minus 2 root x is a negative irrational number, and by the thing we just showed, it follows that this guy here is just f of 0. Okay, so now we've shown that if x is a positive irrational number, f of x also equals 0. F of x equals f of 0. So we've shown that regardless of what number you take, provided it's irrational, f of that number will equal 0. So the last thing we need to do is just show that f of t equals 0 for any rational number t, and then we'll be done. Okay, so now we're going to consider the case where x is a rational number, and what's quite nice about this is we don't have to split it into the case x negative and x positive like we had to do with the irrational case. Anyway, what we want to do is again choose the correct values of a and b to prove that f of x equals f of 0, and there are actually quite a few different ways you can do this, but this is probably the most intuitive way to do it. What I'm going to do is simply let a equal the square root of 2, which we know is irrational, and then b equal x minus root 2. Okay, now because x is rational and the square root of 2 is irrational, a rational number minus an irrational number is certainly irrational. So a and b are both irrational, so we can plug them into that property of f. F of ab equals f of a plus b. So what is f of ab? Well, that's precisely f of root 2x minus root 2 times root 2, which is 2. Okay, lovely. And what is f of a plus b? This is probably a lot easier. This is just f of x. Okay, because the root 2's cancel. So we want to show, we know that these two guys equal each other. So f of x equals this thing here. So we want to show this thing here is f of 0. But notice that the input, root 2x minus 2, because x is rational, root 2 times x is going to be irrational, and because 2 is definitely rational, we're doing an irrational number minus a rational number, so that's irrational as well. So here we've got f of an irrational number, but we've already deduced that f of any irrational number is f of 0. So this guy here equals f of 0, and therefore f of x equals f of 0, and we're done. So we've treated the cases of x irrational and x rational separately, and deduced that f of x equals f of 0 for all values of x, and thus f must be a constant function. Of course, there are infinitely many constant functions, but there are no sort of interesting functions like f of x equals sine x or anything like that that satisfies the properties that we wanted. Anyway, that's the end of the video. I hope you have enjoyed it. I'll catch you in the next one. Have a great day.